All right, this next problem, we're given pretty limited information here, but we have a null hypothesis of P is equal to 0.65 versus an alternative hypothesis that P, and then this should just be a line through, I just couldn't get it to copy. So P is not equal to, these should actually be the same. I forgot to change it there. So make that 0.65. There we go. All right, so we have, first of all, before I go on to the next part of the problem, it's giving you a P instead of a mean or an X bar. So this is a proportion problem. It's going to say it right here, but you should recognize there that that's a proportion. A random sample of 300 observations produced a sample proportion equal to 0.60 using, okay, an alpha significance level of 0.1. Would you reject the null? Okay, here's your null. P is equal to 0.65. This is a two-tailed test because you've got the P is not equal to. So for P is not equal to, this is two-tailed. Okay, so let's get those critical values so we can go through and do this. So for a two-tailed test, and we're using Z, proportions we use Z, okay, you're going to take the significance level, so the 0.1, divide that by 2, so that should be a 0.05. Okay, so 0.05, and you've got 0.05 on either side here. So we want to get that actual Z value. So to do that Z value, you're going to go inverse norm. Okay, then in inverse norm, you put the area to the left. Then you do your mean and your standard deviation. Okay, now we are standardizing these scores. So the mean and the standard deviation will always be equal to 1. So this is inverse norm. Our area to the left, we're doing a left to the 0.05 here. So 0.05 is our area to the left, mean of 0, standard deviation of 1. Let me move this down a little bit. Okay, so in my calculator, second bars, it's the third one, inverse norm, 0.05, comma 0, comma 1. That's going to give you negative 1.65. Okay, so that is my test statistic, negative 1.65. Because it's two-tailed, I'm also doing a positive 1.65. Okay, so negative 1.65 is roughly here. Okay, it's two-tailed, so I've got to do the positive 1.65 as well. Okay, meaning I'm going to have two rejection regions for a two-tailed test. So I'm going to reject to the left of negative 1.65 or to the right of positive 1.65. Okay, so these are my rejection regions. All right, so let's go ahead and do the problem here. So we're given a sample size of 300. We have a proportion equal to 0.60. That's our P hat, our sample proportion. Okay, and then that's it. Okay, so we're given also, we have a P of 0.65. So our P is 0.65. Okay, then our P is 0.65. Our Q is 1 minus P. So that's going to be 0.35, our Q. All right, so we need to find the Z value for this. So our Z value is going to be P hat for proportion minus P over the standard deviation of P hat. Now, of course, we have to find the standard deviation of P hat. That formula is the square root of P times Q over N. Okay, so let's go ahead and do that. So that's going to be the square root of 0.65 times 0.35 over the sample size 300. So square root, and I'm going to do parentheses, 0.65 times 0.35. I'm going to close that, divide by 300, close the square root. I get 0.0275. Okay, so that's my standard deviation of P hat. So let's go ahead and calculate this. So you've got P hat is 0.60, P is 0.65, And then we've got 0.0275. So 0.60 minus 0.65 divided by 0.0275 gives us negative 1.8182. Okay, that's a close one, but this is going to fall in that rejection region. It's going to be like right there. No, just right here, negative 1.82. So it is in our rejection region. So we say negative 1.8182 is less than negative 1.65. So we reject the null hypothesis. Okay, we can also do the p-value approach. You would get the p-value for this, okay, which means you would go get the proportion, okay, or your probability underneath here. You're going to go your upper, before you do that, you need to select the command. So the command is normal CDF. Cannot spell today. Normal, there we go, normal CDF. Then your lower limit, then your upper limit. So your lower limit, because we are on the left side, is negative 99. So negative 99, and then our upper limit is going to be that z value, so negative 1.8182. So that's going to give you your p. So negative 99, comma, negative 1.8182. So 0.0345. Or maybe 46. Nope, 45. Okay, so that's your p. Your significance is 0.1. Now we're actually doing 0.05 since we split it into 2, but either way, it's still going to be less than that. Okay, so if p is less than alpha, you are going to reject. Okay, and in this case, 0.0345 is less than 0.05. So we reject the null hypothesis.